Good day, everyone. This challenge tutorial today we'll be treating a particular topic of quantitative analysis QA. That is set theory. But set theory is a new addition to quantitative analysis, and severally I think like the rate of us is not just doing sets. So basically look at what defines sets and the idea of different types of sets, and from there we'll really talk about the idea of the Venn diagram and how we can apply that to business scenario. So this will actually not take us much time because as far as set is concerned, it's a very easy and straightforward concept as far as that is concerned. So what is the idea of set? I think when we're talking about sets, set just represent the whole of an idea or a concept. So for instance, when we find ourselves in an organization, you can define the organization as a whole, is that okay, or collection. So because it consists of several elements, it can consist of several departments, and each department they can also have different elements inside each of the departments. So you can take a whole and the whole of the organization as a set, and every component that is inside it, we call that elements or members. Is that okay? In one way or the other. So when defining set, use capital to what represent set. So for an organization, whereby you can define the organization as a whole or complete set. In the process, in defining the whole of the organization as a whole as a complete set, in that organization we are going to have different departments, and in each of the departments we are going to have different members. Is that okay? In one way or the other. So we can say the whole of the organization is a set, while different members in which we have that is okay. Define the elements or members of that particular set. So I think we really need to have a good knowledge, a sound knowledge of what define what set. So if we are to define set, we use letters to represent what the overall idea of what of set. So for instance, if we are to define, our main element, so if we are to define our key elements in a set theory, so we can say we are doing set theory. So in a set theory, we can, if you have it, you can say we have a set A. Set A is a set that comprises of ATS2 students. So that means set A, the element of set A will be all of these ATS2 students. Remember, we have Isaiah, I got the spelling of mine. We have Olivier, we have Adiola, Enziva, and the rest like that. So, and so on and so forth. So, we have that to be the element of set A. All of those people, you know yourself, Paul, and those I did not mention. So that defines set A. So all of these right inside set A defines the element of what? Of set A. Also, although we have different types of sets, is that okay? Yeah, we have different types of sets. Like I said, I have the set B now. If set B is something that does not contain, this set B does not actually contain any element, I can use this to be set B to represent the overall idea of set B. I can do this to represent set B. So this set B will be called empty set. So this and this are empty sets. Set B is an empty set. Why? Set B does not contain any element. So we have types of sets. So the first type we talk about is empty set. And what are empty sets? They are those sets that do not have any element in them. Yeah. So they are called empty sets. So empty sets do not have any element defined in them. So whenever we have these categories of sets, they have not. So the cardinality is 0. Cardinality just means the number of elements in that set. I think the number of people I can recognize in ATS2 Isaiah, Onyinye, Adiola, Ezeba, or Fortune. That makes 6. Is that okay? So again, I put dot means I still have some number I've not mentioned. That's why I put the dot. Fortune, this girl name, what's her name? So on and so forth. I think you guys will be around 8. So I can say cardinality of A is equals to 8. That is number of elements in that set. So now cardinality of B is actually equal to 0. Since B does not have any element in it. So set B, cardinality of B is 0. It doesn't have any element. What we are all together. So that will actually explain the general idea of set theory. So set B is empty. Its cardinality is number of elements there is 0. And cardinality of A is 8. I'm assuming you guys are at 8 in class in the TS2. In as the TS2 is what it's concerned. So that is what actually explain this so far. So if we proceed now, we can also talk about another type of set as empty. We can classify set as being finite sets, and infinite sets. So infinite sets. So our finite set now are those sets in which it is possible to list all of their elements. So in the finite set, it is possible to list all of the elements of the set. Is that okay? So we can list all of the elements of such a set. So therefore, we say that set is the what? Is the finite set. So set in which all of the elements can actually be mentioned or can be listed. That means the set has a limited number of elements. For instance, the set A is a finite set. Right? It's possible to list all members. Is that okay? That is in that group. If in an organization, it's possible to list all of them. We're talking about what? Finite set. There are some sets whereby we cannot actually list all of their members because their member has been finite. So we call that sets infinite sets. They have unlimited number of elements. So this set here has limited. This has limited elements. Why infinite? In infinite sets, we have unlimited elements in infinite. So that is just the difference between finite set and infinite set. I hope you understand the overall idea there. So you can say we have a finite set, you can say we have infinite set. In the finite set, we have a limited element. Inside the infinite set, we have unlimited element. So those categories of that is one category of what we said. So if I give a set, you can just look at this set is what is finite, this set is what. For a finite set, most of the way we are defining it, I can say a set A, example of finite set, is equal to even number between 2 and 10. So even number between 2 and 10 includes, or between 1 and 10, between first even number between 1 and 10, or even number between 1 and 10, between the whole number of 1 and 10. So I think we have 2, 4, 6, 8, and 10. So these are the set A, and it's actually what? Finite. Because that is all about the element of A. So set B, if I talk about set all even numbers, is okay? Yes, they are available. So I think we can't list all even numbers. We say 2, 4, 6, 8, 10, 12, and it's continuing that way. So we use dots. Is that okay in one way or the other? Indicating that it's continuing, and we have this. So these are infinite here. So this we use dots to show that it's continuing. It doesn't have a stop. So that is the difference between the finite set and the infinite set. So moving on, we can move to another form of set. Yes, we have another type of set. Whereby we can actually say, okay, we can talk about the idea of subsets and super subsets. Subset and superset and superset. Subset and superset. What defines subset? A subset is okay of another set is any set in which all of its elements is okay contained in another set, which is a superset. So if a set add all of the elements to contain another set, you say that set is a subset of that other one set. So for a superset, is a set in which half, in all of the elements, you have all of the elements of other sets defined in it. For instance, if you say, okay, I have an A, and A I have 3, 4, 5, 6 in A, and in B I have 3 and 6. So we can say that B is the subset of A. And B in one way or the other depends on A. Is that okay? Now sometimes we can also say proper subset. If a proper subset is a form of subset, so B is the subset of A, or we can say A is the superset of B. So A is the superset of B. Why? A has all of the elements of A contained in it. Why B has all of the elements contained in A. So B is the subset, A is the super subset, A is the superset, sorry. Now we speak about proper subsets. You can say B is the proper subset of what of A. Why? Because what happened? As A is concerned, A has some elements, is that okay? They are not in B. Is that okay? Yeah, at least there will be some unique elements in A which are not in B. If we have to say B is a proper subset of A. So we can say B, by knowledge of proper subset, is a proper subset of A. So to show that A is so unique that we still have to use some elements that make it unique from B. Is that okay? Yeah. That proper subset defines how uniqueness that super subset is from the subset. Is that okay? So that means we say A has elements of 4 and 5 which are not in B. So and B is a subset of this, but is a unique subset, is a unique superset of what of B because it has some elements which B does not actually has. So that is what actually explains the knowledge of subset and what superset. Now let's talk about what we call the power of the set. The power of the set defines the amount of possible subsets. Power set. The power set defines the amount of possible subsets in a given set. For instance, if you have a set A that has just 2 elements, it has 3 and 7 as its elements. The element of set can be number, it can be 50, it can be anything. Is that okay? One way or the other. So this is the element, just 2 elements. The list of all possible subsets define the power of the what? The power of the set A. So you can say power of set A will be the empty set. The empty set is the subset of A. You know that the set A, the element, the set that has 3, the set that has 3, the set that has 3 as elements. It has 3 as its elements. The set that has 3 as its elements. The set that has 7 as its elements. The set that has 3 and 7 as well as elements. So that is that. Also, we can say, hope we're listening. We can as well say power set of B. Let's say you have a set B. Power set of B. Let's say set B now has element of 1, 4, and 8. Power set of set B will actually go this way. Will be empty set, comma. A set that has 1 as an element, comma. A set that has 4 as an element, comma. A set that has 8 as an element, comma. A set that has 1 and 4 as elements. A set that has 1 and 8 as elements, comma. A set that has 4 and 8 as elements. A set that have 1, 4, and 8 as elements. It also is a subset of B. So although 148 will not be proper, one others will be proper, but 148 will not be proper to state of B. Because the B is not unique. So let's determine that we have 1, 2, 3, 4, 5, 6, 7, 8. So yeah, success here is actually is 4. The power set here is 4. Power set here is what? Is 8. What if we now have set that element of 4, 5? You know how it's going to take us. So we have formula for power set. So it's the OBJ question. These are the questions you will be asked in OBJ, and I wouldn't want you to throw them away. So I really want you to utilize the power, utilize the power and actually enjoy the power, is that okay, of the knowledge. So it's not hard at all. To get the power set, for instance, power set of what? Of any set, let's say set A is maybe like this. Is that okay? It's giving us the power set is giving us 2 raised to the power n, where n is the number of elements. For instance, power set of A now, originally here, can be defined. Power set of A can really be defined. Power set of A can be defined as 2 raised to the power 2 because n is 2. Is that not 4? It was 4 we got earlier. So power set of the third of B, power set of B will be 2 raised to the power 3, and that will give us 8. So that is just the overall from there. So I hope you understand. So that is about power set. So power set of any set is 2 raised to the power n, where n is the number of elements. What is the power of the set that has 5 elements? They are waiting in 5 seconds. I hope you got the answer, and that is 32, which is 2 raised to the power 5, 32. So that is just the overall formula. So let us move on. So the next thing now we can quickly talk about, since we are done with the issue of power set, is for us to quickly run through the overall idea. Is that okay? The overall idea of let's quickly run through the overall idea of universal sets. So universal sets. So maybe we say global sets. The idea of universal sets define sets in which all other sets are drawn from. I think you should, if someone refers to the idea of the word universe, you should understand what universe. We're talking about the whole, which other things depend on. So universal set is the set in which all other sets are drawn from. That means you can say all other sets are subset of universal what? Set. For instance, if I say set A include all numbers between 1 and 10. Is that okay? Oh yeah, what are the one numbers between 1 and 10? 1 is 2, 3, 4, 5, 6. Keep mentioning until you get to 10. Like that doesn't mean you keep counting until you get to 10. Set B is now all the odd number between that 1 and 10. Odd number 1, 2, 3. Jesus. 2 is not another number. So we have 1, 3, 5, 7, 9. These are the odd numbers. C, then C is now all even number between that 2, 4, 6, 8, and what? And 10. So let's say now D is now all prime number between that. So we have 1, 3, 5, 7, and that will be all. So looking at this now, this is our B, C, D. All B, C, D are subsets of A. That means we can say A is a universal set, while B, C, D are what are subsets. And I hope you understand that. So these are not really complex. They are straightforward concepts. They are things that you can actually pick and have a good understanding of or knowledge of. I don't think they are really complex in any way. It's okay as far as what they are concerned. So we can say B, C, D are subset of A. Therefore, A is a universal set to them. Is that okay? The one way or the other. So operations in set now. How many characters operation in set? So in sets, we have what we call the idea of the union and combination of sets. We have what we call the intersection. Let's have the intersection actually. So we have what we call the intersection of sets. Intersection in sets, which is represented with this. Yeah, that symbol represents intersection. We have open union, union is set, which is considered with this. We have a tie symbol for union. We also have the idea of complement of sets. This one is not really operation. Should I just talk about that? Complement. This is not really operation. Complement. I hope you can spell complement. So complement of sets. So now, what is the intersection of set? Intersection between two sets, A and B. For instance, A intersection B. Intersection between them includes all the elements that is common to both A and B. Is that okay? All element common to both A and B is called intersection. If I define my A to be a set of 1, 4, 3, and 2, I define my B to be a set of 7, 2, 1, 3. You can say the intersection between A and B is 1, because 1 is in this thing. 2, intersection and what and 3. That is what is common to both. Now, union, A union B, what is now union of sets? Union of sets define those sets that are in what that in A, there is also in B, is okay, or in both of them. That is set that is one way or the other. Those all the elements that are in both sets, either in A only, or in B only, or in both of them. In as much that set belongs to that element that is in A only, B only, or in both. In another element is in either of the two. So it includes all elements that are either A or B or in both. Is that okay? So you can combine all the elements. So what are the elements? Is one does one exist? Yes, one is one of them, comma. Does 2 exist in any of them? Yes, 2 exist. Does 3 exist in any of them? Yes, it does exist. Does 4 exist in any of them? Yes, 4 exists in A. It's part of the union. Does 5 exist in any of them? No. Does 6 exist in any of them? No. Does 7 exist in any of them? Yes, 7 exists. Does 8 exist? No. Does 9 exist? No. Does 10? No. So this is the union. So the A union B is what is this. What is now complement? Complement just explain those sets that we have in our universal sets, which is not in that given set. So that let's assume you are done with union. Let's really talk about complements of sets, set complements. We have set complement of A is written as A complement or A raised power C or A prime. That is the complement of A. For instance, if I have a universal set, U, non-union, U means universal. So, and it's defined as 1, 2, 3, 4, 5, 6, 7, 8 only. This is my union. And I have B, set B to be actually defined as 3, 4, 5, and 8. This is set B. What is B complement? That will be those elements B prime. B prime is means B complement. Those elements that we have in the universal that is not in what that is not in B. So that those elements, that we have in the universal that is not in B, those elements. And what are the elements? Those elements actually includes 1. 1 is not in B, comma, is in the universal. 2 is not in B, comma. 3 is in what is in B, so it's not a complement element. 4 is in B, it's not a complement element. 5 is there, it's not a complement. 6 is not there, comma. 7 is not there, and 8 is there, so 8 is not a complement element. So complement of B is 1, 2, 6, 7. That is what actually defines complement. So I think we are good. We can just quickly go back to the idea of our theory, so we can have a good knowledge. So if we actually look at now, I think I've given you the shared knowledge already. So I think we are told on how to define sets. Is that okay? We are told on how to define sets. We said the definition of basic terms in set theory. A set is the collection of all defined objects, things, or units. Collection, exactly the whole, and defined at the beginning. The objects which are called members or elements will be well defined. You have to determine and ascertain whether a particular object belongs to the set or not. So you have to define rules for defining the word, the element. For instance, if I say set A consists of HL students, what is the ring shining green? That means I've defined you guys well. Those people that what that is in ACS2 that is coming to work to shining green, is that okay? One way or the other. Always available. Those that could not remember you, and that are not available as far as this guys is concerned as in doing in completing this video. So instead the representative of denoted by capital letter, what an element by small letter. So the symbol used in set are what are used to represent itself. So for instance, we are saying that okay, as set is continuous, is that okay, one way or the other. You can be like B, E, B, and it's more B. But element are represented by small letter. Set are represented by capital what letter. So we are saying B is an element of what? Of set B. So B belongs to set B. Element belongs to B. Not this one is telling you that B is not an element of what? Of B. So you can get sets in 10 different ways. You can actually get the set by listing all of the elements. This is called a roster method, whereby you list all of the elements complete. Yes. By describing them in some way, either by mathematical element or properties. So the set A is the what is the X and S is an integer. So that just time we set A must be an integer. So we have types of sets. I've done that. Finite and infinite. When the number of elements or number of elements in the set is countable, then the set is said to be finite, otherwise it's infinite. So we have odd numbers between 0 and 12. We can count 0 between odd numbers, or we can count all odd numbers between 0 and 12. That is 1, 3, 5, 7, 9, 11. So this is the set in A. So we have set B now. Set B is infinite. So I've said 1, 2, 3, and it's continuous. Then I'm talking about set of all countable numbers. Is that okay? Or positive integers. That does not have a stop. So based on cardinality or number of elements in the set, that is the cardinality defines the number of elements in the set. We use small n to write beside that set. So we said set A now has elements 1, 4, 7, 8, 5, 6. What is the cardinality of A? How many elements do we have there? We have 1, 2, 3, 4, 5, 6. So cardinality of A is 6 elements. So empty set or non-set. This is set with no elements. It's denoted by the symbols. Is that okay? The set of integers that are both odd and even is an empty word empty set. We also have this idea of called universal word set. This is the collection of all conceivable objects of that consideration. So U is the symbol used to denote the universal word set. So U means all English alphabet. That is universal. Is that okay? All students in college, so it signifies all of the sets. Now subset. I think I've explained something that goes to you. But if all the elements of the set are contained in another set B, then set A is a subset of set B. That means if the elements of set A are contained in set B, then set A is a subset of B, while a B is not a superset. So in a symbolic form, it is written as set A is a subset. That symbol means subset. And this is the way I wrote it earlier. If I know you follow me, I wrote it exactly the same way. But it's subset. It can be written as that B is a superset of A. The symbol means superset. Note that if all the elements of A are also the elements of what? Of B, then A and B are equal set. Is that okay? Yeah. And that means there is no unique element in B in one way or the other. There will be an equal set. And that then being equal set, A will not be a proper subset. Is that okay? There will be equal. That's why I actually explained the point there. For instance, set A is 1, 2, 3. Set B is 2, 3, 2. There are A is the subset of B. B is the subset of what? Of A. They are equal sets in one way or the other. So the other element does not matter. So you can say, okay, we have G. G is ABC and F is AECB. So you can say D is a subset of F. So union of the set now is the set that contains what? Consists of all elements or point of set belonging to either A or B or both. Is that okay? In one way or the other. A union B means set by the word that is A. This is in Venn diagram. This is how we can represent union between A and B. The Venn diagram is a diagram that enables us to represent set information in their intersection, in their union. Is that okay? In the form of what? The diagram. If the owner of the diagram is John Venn, that one is called Venn diagram. His name is Venn, VENN. So that's why it's called Venn diagram. So this is set A, this is set B. Maybe we can just use our display and we'll show that to you. So I think we have Venn diagram and we have two sets defined already. So This is set A and this is set B. If I'm to define my union is what is the A only? This A only here. Is that okay? And this B and this B only. And this is the union. So what is A, B only, and union? Everything here is what we call our. So this is everything here is defined A union B. Is that okay? A union B. So that was actually explained we were opening there. So introduction of what? Of set. A condition B means set that is common to both set A and B. So we are saying set a portion of the set that is that is common to both. That's why it's called section. We use that symbol to represent that as you can see. I hope that you can read alongside with me as well you can see the screen. In as much you can see the word the screen. So this is an A, this is from B, and the middle defines their what? The point of their intersection. So we also have what we call the complement of set. Complement of the set A is a set containing all the elements in the universal set, but not in A. It is related by what? By A prime. So also that what is in the universal set, but it's not in set A, in the defining complement of what of A. All the answer box now are we have a set A in our Venn diagram. So in set A, this is inside of our element is belonging to A, outside the what are the complement of A. All of the diagram is what is the universal. Is the universal. So let's look at this now. We have to list the elements of each of the following sets. So we have sets. So we are taking an example now. I will be solving. We usually use Venn diagram. So we have this element of each of the following sets. X is odd number between 0 and 1. That we set X will be 1, 3, 5, 7, 9. So set X is that. And I think you should learn it. I'm not going to write the symbol, but you can always write the set symbol in that manner. So set Y now is odd numbers less than 20. Odd number less than 20 is in group 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. So as you can see, Z is now even number between 9 and 31. The first number between the first even number between 9 and 31 is 10. So 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. So that is just the of Z. So between 31. So 32 is the next even number, but we said between 31, 9 and 31. So applications of business-oriented problem using Euler's Venn diagram. Euler, so John Venn, some people say John Euler's. Euler Venn diagram. So I think we need to explain Venn diagram. Venn diagram is just a diagrammatical representation of set theory. Is out in one way that we show different problem of sets in one way or the other. So I think we can just look at the good display of set. This is union here. So let's test how good we are to this overall knowledge. So let's say we are dealing with intersection. So if you have a single set, so in a single set, so let's have this set A. All of these now are the elements that belong to A. So these elements that belong to A. After that do not change, everything here is universal. The union universal. So everything here, everything in the box is universal. So these are the elements that belong to A alone. Outside that means those outside that do not change and do not shade element that do not belong to what? To A. So this is how to explain this. So I can just in one way or the other erase let me erase and withdraw and shade the complement of A. So if you have A, so you can see what the shaded part here are what are A complement, or we can say A prime. That is the shaded portion. So that is another way of defining that. So and we can go for the around that shaded is the cardinality of A. So if we want to explain the intersection, for instance, in two set theory, if we have set A, this A and this B. So this place here, what is this place representing? This place I'm trying to shade. Or that part I'm trying to shade. So that part is actually our A intersection B. That is our A intersection B. So also I can say between two sets I have this defined. Between two sets I have sets. I have A here and this is my B. So if I shade this place alone, that part I shade alone is defined as A intersection B prime. I mean, what is in A and not in B? What is in A only? Is that okay? That part, I didn't shade it to this part here. Do not get to, that belongs to A only, does not belong to part of B, or when they intersect. Also, if I have a set theory like this, so Venn diagram gives us the law of knowledge. I have this, I have this. So this set A and this set B. And I actually shaded this part below. Think I'm listening to. So if I do now, shade this part. It does not get to the intersection now. So we shaded that part below. So that we will not shade the intersection. So we have A prime. What we have is A prime intersection B. So A prime intersection B. So A prime intersection B is where we only shade part that belongs to B alone. Not shade what A. So I think we know if we shade outside and we don't shade inside, that would be our what? So we can also have more within the two sets theory. Hope you are writing. You can just take the video back and write it. If you be saving it, you can always go back anytime. This set A and this set B. So if I now shade all outside, what have I done? So here what we just did here is what we call A union B all prime. And what does not belong to A does not belong to B. It does not belong to any of them. Or some people will say A prime intersection B prime. That is another thing there. A prime intersection B what? B prime. So that is another area here. So another thing you can define in set union in sets is in two sets is this. We call that disjoint sets. A, B, this B, this A, and they don't have and do not meet. Is that okay? So we can say A and B are what are disjoint. So A, B are these joints. So that what are the disjoint sets? Sets that do not have anything common. So we say A intersection B for a disjoint set is what? Is equals to, is that okay? Is equals to empty set. Is an empty set. Is that okay? And cardinality of intersection, number of elements of the intersection is equal to 0. So number of elements of the intersection is equal to 0 because they are disjoint. They cannot never have any element in common. So the set A union A intersection B is empty for a disjoint set. Is empty for a disjoint set, and also the cardinality number of elements of the intersection is always 0. It will always be 0. Let's talk about for a 3 element for a 3 set rather for a 3 set. When diagram is a 3 set. So the diagram is a 3 set will be illustrated in this manner. When we have set A, we have B, and we have C. So I now shade there, this is our A, this is B, this is C. I shaded only part of A. Yeah. I shaded that. So this will be defined as A intersection B prime. That is, it does not belong to B intersection C prime. So it does not belong to B, it does not belong to C. It belongs to A alone. So that is what I actually explained the overall from here. It does not belong to what to B, it does not belong to C, but belongs to what? Belongs to A. So that is that. Another knowledge of theory is this. You can say we have this. Okay? So that is one knowledge. Let's keep that with you. Another one is this. We have a set, we have something like this. So we have set A, set B, set C. So we now have this part shaded. This part here. So what we have there is A prime, is that okay? B intersection B intersection what? C prime. That means we are saying what does not belong to A, but is in B and does not belong to C. Is that okay? So that is just the part there. That is the part. So let's see, can we do another part? We have enough space to draw another. So we just shoot another one. Okay? So this is A, this is B, and this is C. So let's say for instance we shaded the part of C alone. If we try to shade the part of C alone in one way or the other. So that shaded part is A prime, intersection B prime, intersection C. That means does not belong to A, does not belong to B, but belong to what? To C. So that is just the order of the. So another thing we can shade in 3 by 3, another thing you can have in 3 by 3 is you can define this. So we have A, we have B, we have C. So if I shade here, just this portion here, is that okay? I have this shade in that portion. So that means I'm saying A prime, intersection B, intersection C. That means what does not belong to A, but belong to B and C only. That is the meaning. It does not belong to A, but belong to B and C what only. So also we can have this defined. So we can have something like this. So this is my A, this is my B, and this is my C. So I now actually share this part. So share this part one way or the other. So what I have here now is A. Oh, I've done that before. Let me clear. So sorry, I've done that. That is A intersection. Okay. So I've done that before. So that means we have this. We have this and we have this. We have A, B, and C. And I should get this part below. This part of here. What does that mean? So I'm actually saying it belongs to A. It does not belong to B, but in any way, but it belongs to C as well. So when it's common to A and C, but it does not belong to B. So that is what that part is saying. And I think that is very straightforward to be able to grab. Straightforward, easy, and straightforward. So the last one we can really talk about now is this arena here. So let's assume we have this. So we have A, we have B, and we have C. So assuming I'm actually let this part now. What does that actually mean? It means it belongs to A, it belongs to B, but it does not belong to C. Yes, it does not belong to C. So it belongs to A and B, but it does not belong to C. Alright, let's pick another one. So I hope you actually get that. Because if I'm too fast, you can always pause the video. One more. So another we can actually consider is actually we can consider another. So I think we have this. So we have A, we have B, and we have C. So you can change this part here to this part here. So that part that we just shaded here is the part that belongs to A, intersection B, intersection C. That part belongs to all the three. All the three. Yes, all the three. So that is that, as far as that part is concerned. So I hope it's well explanatory. Yes, it belongs to all the three parts. Yes. So another thing I actually have is this. So let's assume we have A, we have B, we have C. And all the shaded part is this. So we have this one shaded. We have this is the shaded. This is the shaded. This is the shaded. So all this place here that we just did is A, union B, union C. That means it belongs to A, B, C. Is that okay? At once. So So all of these elements belong to the ABC. That is that. That is that. So that we can talk about for a 3 set is if we have this, the 3 set defined in the 3 set. If this is defined in the 3 set. So we have set A, set B, and set C. We now define the asset outside of the set. We define the outside. And define the outside of the set. This way. And define the outside. So this that we just did now is A, union B, union C, or union C, or complements. All complements. Is that okay? All complements. Not complement of C. All complements. Is that okay? Or you say complement of A, intersection complement of B, intersection complement of C. So that is that. So that is just the point. I hope you understand. I hope you understand it. So that's just what I actually explain the overall point of this knowledge. So now I think we can go back to our example. And I think with that knowledge now you can just pause the video, rest a little bit and go back. I hope you'll be able to proceed that way. So now we go back to just building diagram and I think we'll kill it now. We should be able to kill it now. So question said in the market. Okay, let me just give us an important knowledge in set theory. I just remember this knowledge now. Yes, let me give us that. I think that will also enhance our knowledge as far as set theory is concerned. In every 2 elements of set, is that okay? Cardinality of number of the union. The number of elements that is in both A and B is always given as number in A, number in A plus number in B minus number of the intersection. Number of the intersection. So let me just go down and write the 2 set elements. Union of A and B is given as number in A plus number in B minus number of the intersection. Number of the intersection. Number of the intersection. This is intersection. Let me draw that. So the number of the intersection between A and B. Number of intersection between this cardinality of A and B. I'm sorry. So that is that. With this knowledge is very important. Some question, you can solve some question without you not having to use Venn diagram. Is that okay? If you have a good understanding of this. With a good understanding and little understanding of set theory, you can actually kill the question without you having to prepare. Is that okay? On that. So this is the overall knowledge. Also, we can say we have we are only talking about the union. Is that okay? Is number in A only, number in B. So the total number in A, total number in B, and the total number of the intersection. And we have our union. Is that okay? We have our union. The number of the universal, the magnitude of the universal will be equals to, do not forget, this universal, U. Yes, number of the universal set will be equals to number of the words of the union, total number in A and B, plus those numbers that are not in words, that are not in